Welcome to everyone who has joined, and of course, to our esteemed speaker on behalf of AMNS India. It actually gives me great pleasure to introduce our new endeavor, which we are calling Smarter Conversations. This is actually a series of knowledge sharing sessions. This is just to encourage dialogues, have debates, drive new ideas. Ultimately, the goal is to reach a smarter future for us, for all of us. Each of these sessions will be based on themes which are, of course, very important to us as a community. It will range from energy to infrastructure to sustainability and whatnot. Sky is the limit. I am happy to see so many people are interested and they have joined in such large numbers. And I do hope that you enjoy these sessions as we go further. Meet, over to you.
Thank you, sir, for commencing the webinar series Smarter Conversations. Before we dive into the webinar, I would like to introduce our esteemed speaker for the day. It is a pleasure to have you, Mr. Francis Suresh Balan, who is the Managing Director of CGSGreen Sustainenergy Pvt Limited, a distinguished solar expert and a sustainability auditor with over 17 years of experience. Mr. Balan has worked with over 400 industries and led more than 2,500 megawatt of solar projects globally. As a consultant to the Asian Development Bank and the World Bank, he has received accolades such as Pride of India Award and Future Green. His insight into large-scale solar strategies are truly invaluable. Let's hear from him on today's topic, Scaling Solar, Strategies for Developing Large-Scale Utility Parks. Over to you, sir.
First of all, good afternoon, everybody. A warm welcome to you all. I'm very happy to see you, a large community who has, come across for this webinar in this today's, Thursday afternoon. And I would like to thank AMNS India for this initiative and inviting me for this subject as a speaker, and which is not just close to my heart, but also a critical point which we need to address when we move forward future. And over the years, I have seen various transformation in the sector. When solar, 1 megawatt solar was almost installed for 16 or 17 crores per megawatt, whereas now it's almost 3.5 crores to 4 crores per megawatt. So, which various industries, communities have got benefited out of this various solar projects, and governments have also given various schemes, for developing a ground mount project, rooftop project, in rooftop also large scale and also small scale like Suryagar and all those things. PM Kusum scheme especially for agriculture sector solar projects. So we will discuss one by one in the forthcoming slides. The presentation is going to be almost maybe 45-50 minutes, and we will have the question and answer session maybe at the end of the presentation. So this particular topic, especially when NMS team asked me, so I said, yeah, very well, we can do it, and I'll also try to share what all experience I have, both positive and negative, in this sector, and we are going to definitely discuss one by one. So, like I told you, all these question and answers we will try to have, at the end of the session. Please hold on, and in the comment section you can add all the questions. See, when you compare to the, when this national solar mission was launched in 2010 till now, if you see, there has been tremendous growth in solar sector, and almost even if till April 2025, if you see, almost 97 gigawatt of solar capacity. Either that includes rooftop, ground mount, everything, all the small scale and large scale projects. Almost 97 gigawatt we have installed so far, and this, out of which ground mount alone, it's almost 75 gigawatt. And there are various environmental impacts, has been positive impacts were there, like carbon emission reduction due to this large scale projects, and economic advantages where we created large amount of jobs for installations, commissioning, and maintenance activity. Various supply chain also got benefited because of these projects. Some of the key challenges, what we can see is maybe the land acquisition complexities. Previously, land acquisition was much more easier, and now acquisition is a little bit difficult compared to, but it's not like we cannot solve that problem, but it's a little bit difficult. Everybody cannot just like that acquire land, especially for solar project. And now even farmers, whoever wants to sell the land, their eyes were also open now. If nearby farmers selling an acre of around 10 lakhs, definitely the other farmers will also. It's a kind of everything is linked. Everybody knows what is the demand for the solar right now, and there is some of the environmental and ecological concerns are also there, and some challenges I can say is grid integration and infrastructure limitation. And as far as India's solar landscape is concerned, like I already told you, the government solar alone, it's around 75 gigawatt. And there has been so many initiatives was provided by Government of India, starting from National Solar Mission till the PM Kusum scheme, which is the recent one. And there are various state-wise solar policies were available. Various states have developed solar parks under the initiatives of Government of India, and our renewable energy target also got revised. By 2030 we will plan to at least achieve 500 gigawatt, and almost 50 percentage renewable energy mix we are expecting by 2030 in the overall energy mix. And as far as challenges in achieving target is concerned, like I told you, land availability, financing, grid integration could be one of the challenge. And these are all the various large scale solar projects that got implemented so far. This Badla Solar Park is the one of the highest. Most 2.2 gigawatt got implemented, and similarly in Pavgada 2050. The lowest would be maybe in Badla, Rajasthan, Charanka, Gujarat, 500 megawatts. And yeah, so this graph it shows the various states how much large scale utility projects got implemented. In Andhra alone, it's around 3,000 megawatt, and in Rajasthan, it's around 2,745 total projects. So compared to various sites, project got implemented, and in Karnataka, 2050, and in Madhya Pradesh 1350, and 648 in Tamil Nadu, which is Kamudi plant, and Gujarat 500, and Chhattisgarh 500. And if you see the growth from 2014-15 till 2023-24, almost 70, almost we from 3.7 till 74.3, we have grown a lot till 2024, and even we have grown a big way in 2025 also. Like I already told you, 97 gigawatt we have achieved. Coming to global context, various countries which has achieved various capacities. China is a global leader now. Almost 400 gigawatt of installed solar capacity they have. And as far as USA is concerned, they are emphasizing on hybrid system, advanced energy storage system solutions and all those things. Hybrid means like wind solar hybrid, wind solar green hydrogen or battery mechanism and all those things. And as far as Germany is concerned, they are making community driven and decentralized solar models. We will see one by one in the later this thing. And India is almost fourth largest in solar capacity globally as of now. And there is a huge demand for clean and renewable energy sources that is there in globally. And there are international collaboration which we may have to look into it, like scope for technology transfer and investment and policy exchange. As far as technology transfer is concerned, I will explain you in the last slides, because some of the technology US has already invented and which is yet to come to the market. And as far as common challenges are concerned, land availability and competition for space, that is one challenge, and need for consistent and solar policy, supportive solar policy is one of the other challenge, and grid stability and resilience. Even though if you implement solar projects in any land or something like that, the grid connectivity and the transmission lines infrastructure to be developed from the government side only. Even if some delay happens to come, project will delay. So those kind of challenges also we have to overcome. As far as initiative, whatever government has made, MNRE Solar Park, that has a target nearly 40 gigawatt, and product linked incentive basically to promote domestic manufacturing. And the government has almost allocated 4,500 crores, especially whoever is interested in setting up module manufacturing. But anyway, the cells, as far as cell is concerned, we are still importing from China. But due to Make in India, initiative is also there. So government is promoting product linked incentive, especially for domestic manufacturing. And PM Kusum scheme and decentralized for decentralized solarization. Basically, Kusum scheme is basically linked with the agriculture land and all those things, water pumps, agriculture lands, and agrivoltaics and all those things. So these are some of the initiatives the government have already taken. And as far as state level policies are concerned, we have in Karnataka and Gujarat separately solar policy. We have rest of the other states we have renewable policy, which comes under RP obligation. There are some policies also which states have formed, so which is in a draft stage now. And other initiatives what government has done is like tax incentives and subsidy for solar projects and RP obligations, RECs. Even now REC can be traded internationally, which is IREC certificates. and grid connectivity policy for solar parks, especially framed for it, and various initiatives. Like, just to explain more on the initiative side, basically, on June 30, 2023, almost 37,990 megawatt has been sanctioned across 12 states to be getting implemented for large-scale solar projects. And through various schemes, SECI is also implementing projects like say 500, 1000 megawatt through reverse auction, where the tariff is also coming very competitive. And as far as SECI projects is concerned, people are very much, like, investors are very much interested because their payments are secured. But there are some challenges which we are facing in a couple of discoms. I cannot name those discoms, but in many states, the payment to the IPP is one of the major challenge, which is sometimes getting delayed 2 3 months, 6 months, 1 year, and all those things. Because of that, investors coming forward towards implementing those projects in particular states, they are reluctant and they are not interested. So those kind of challenges, if we address, definitely there is a huge potential for growth as far as the sector is concerned. And like I told you, product linked incentive. So almost government is promoting to have a cumulative production capacity of almost 8,737 megawatt. So that is the target basically. So I think there are many manufacturing units have been already started by various big chains utilizing this scheme, and some more manufacturing units are in the progress, which will be getting implemented. And other initiatives apart from the previous initiatives, whatever we have seen, in order to promote rooftop programs, there is a solar rooftop program for large scale, for large rooftops like industrial rooftops, commercial rooftops, which varies from 200 kilowatt to various megawatt scales and all. And apart from that, PM Suryagar scheme, we all know the government of India, and through the state discoms, they have empaneled various EPC vendors who can implement projects in the rooftop of domestic basically. And there is a subsidy of 40% up to 3 kilowatt, and above that, up to 10, it's 20 percentage. So because of that, PM Suryagar scheme is also picking up, and almost many rooftops got benefited because of this scheme. And Yojana scheme, especially integrating solar powered irrigation system and the agrivoltaics and all those things. So these are other initiatives which government has taken. And as far as importance is concerned, when you implement a large scale, solar projects, there is a efficiency improvement in the cost, because per megawatt scale project that will drastically come down. Because when projects are getting implemented for 5 megawatt and 500 megawatt, the cost per megawatt is obviously, there is a huge difference. And one more importance or advantage I can say is the centralized facility. Pooling substations can be common for various nearby power stations also, nearby power plants also. For example, if I have 3 megawatt and somebody has 5 megawatt nearby, so we both can share the expense to implement transmission and distribution line and pooling substations and all those things. So that cost can come down. Shared infrastructure is one of the important benefits, and grid support should be there. That is also one of the this thing. If grid stability is not there, certain things which government has to give approval, and if discom doesn't give, or if discom delays, so then there will be delay in the project. So that is also one of the important thing. And the next thing is energy security. So we will stop relying on the fossil fuels, and it will strengthen our energy independence, because various fossil fuels are getting depleted. That you all know, that I no need to tell. Everybody knows that conventional power will be slowly getting replaced. It's already got replaced, and it will slowly replace with renewable energy or other things. And there are development challenges. Again, challenges we have already seen. So as far as site selection strategies are concerned, we will initially see the land suitability, whether what kind of land is it, whether it's coming in wasteland, wetland, forest, agriculture land, all those things. Grid proximity, which is whether the grid is nearby, the substation is nearby or not. Even if substation is there, whether the allocation of the power, whether substation can take up the power or not, that capacity, so those things we'll see. And environmental sensitivity, if it is a forest area and if any species are getting affected, so the project has to undergo the environmental impact assessment of various resources like soil, water, air, all these things, plantation, flora, fauna, everything. And other strategy would be GS based planning. So where we will mark the boundary, and we will try to put because this is one of the major thing where when we design the power plant. And also we have to assess the solar potential based on the radiance that is available, temperature, and whether the climate is suitable or not, whether more dust will be coming in that area or not. So accordingly, we have to plan the cleaning mechanism also. And according to the resource availability, how the generation potential is going to be there. what is going to be my PLF, plant load factor, and all those things we will be doing. And there is a software also, PVSys, Helioscope, and PVSol, and all those softwares. Using that, we will identify how much potential could be installed and how much generation is there, and how much power can be exported to the grid. So those things we will address before even implementing the project. And as far as land acquisitions model is concerned, I think in Pavagada they have acquired like in a leased model, like 21,000 or something per acre or something like that. I'll show in the forthcoming slides. And leasing and purchasing of land is one of the two models which is available for land acquisition. And as far as community engagement is concerned, we can try to involve the local stakeholders are getting involved, local panchayats or local people. Job creation is there. Those kind of things are there. And environment assessment, I already told you, we have to do the EIA, environment impact assessment, and we have to clearly see whether any ecological impact is there or not. And we also have to give a mitigation measures. Suppose, and we do a social assessment apart from environment. Suppose if a community is living in a particular land or something like that, and which is very close to forest area, and where project also approved to get implemented there, and the entire community needs to be reallocated with some land or the other land or something like that. So those things we have to see. And there are many projects where because of these reasons it got cancelled or something like that. Coming till now, we have seen some of the strategies and some small background and all those things. You can hold your questions till the end of the things. This you might be all the solar people, they already know what are the components that will be available. This especially for the people who someone who is attending who's new to solar field and all those things. So initially this is the SLD, single line diagram. So panel will be there. There will be DC combiner box. Mostly in the large scale project, we won't be having this. So directly it will go to inverter, and then there will be ACDB, AC distribution box, and from that it will be connected to the panels, LT panel transformers, and from there it will go to the grid. Grid means the transmission lines and distribution lines. And we will have a monitoring mechanism also, which will be usually online, which will come up along with the inverter basically. So there will be some of the applications available. Through that we can monitor how much energy is getting generated, and through ABT meter, if it is a smart meter, we can even see online, how much power is getting exported also. There are various components. I can easily skip this module, inverter in structure. There will be meters, generation meters, and also the AC side meters will also be there to calculate how much energy is getting exported to the grid. And we have to give DC, AC, and LA things and all those things. And lighting protection we may have to give if there's a tall structure is there. Generally, if any inverter room or something like that is constructed, we have to give a proper LA. For that LA, we have to give earthing, and various cables like DC and AC cables we will be using, connectors, lugs, and DCDBs, and various MC4 connectors. Everything we use along with SPDs, surge protection devices. Apart from that, data monitoring online system. As far as PV array is concerned, mostly right now we are using either bifacial or else monopuck. These are various technology was available since like from the past. Thin film, monocrystalline, polycrystalline was there in the beginning, and now monopuck, bifacial, and now one more new technology has come, which I will be discussing in the next coming slide, which is perovskite. So that is also one technology. And as far as bifacial is concerned, as of now, bifacial is one of the highest efficient modules where the generation can happen both the side, and through MC4 connectors and through DC arrangements, the power is getting transferred to the inverter, and from there it goes to the grids. And when you select a module, we may have to look after various certifications, which is linked to IEC and BAS, and we have to see the manufacturer credential, their data sheet, their test certificates, and everything we have to see. And as far as companies credential is concerned, whether they have ISO 9001, 14001, and all those things we have to see. And warranty, product warranty, whether for modules up to 25 years where they have to give an inverter for 1 year, 5 year, and accordingly the cost of the inverter also varies. So those kind of warranty statements and warranty certificates we have to get. And bill of material, we have to see what kind of BOM they have used for manufacturing this module. And module testing, usually this electroluminescence test, and electroluminescence generally it will help us in detecting micro cracks in the modules. And even thermography we will do generally. It will be helping us to identify the hotspots in the module, because if there is a small damage in the module, if it is there, hotspot will be created in a particular area, and automatically module will get overheated that area, and the inside that there will be a ribbon that will be connected to the each cell. So if that is gone, then the generation will not happen for that particular string. So that is one of the major reason we do this real and also thermal imaging for the modules. And when we select an inverter, all as usual, we have to see the certifications, manufacturer credentials, and warranty, how much they are giving. And mounting structure is concerned, we have to see whether we have to go for a GI or MS based, mostly GI, what we are doing, what we are putting in the ground mount, and whether the structure is able to have a thermal expansion or not, because in some areas there will be overheat will be generated, and in some area it will be very cold. So that expansion and this thing coming back to the original position, so that is there or not, we have to check. And mechanical load compliance, how much load it can take, those things also we have to see, and whether the load is able to withstand the wind load or not. So wind load study we will be doing generally if it is a large scale project or not. And also we have to see whether that area will dusty, or if the snowfall area is there, snow will be deposited on the module. So those kind of things we have to assess before itself. And corrosion resistant, whether GA is corrosion resistant, whether anti-corrosion paint is done or not, all these things we will be checking. Applicable standard for this is 6253548. And there are various BOS components which we'll be using: DC cable, AC cable, overcurrent protection, which I have already shown you on the other slide. And also apart from that, we will be doing some marking and signage also, saying that this is danger area, high voltage area, so no, don't come near. So like that, we will have to put some danger marking signs as well. So this is how it's going to be. Like we will be mentioning live during daylight, dual supplies there, inverter, AC isolator. So this kind of warning and signages we have to provide. And as far as site assessment is concerned, we will initially go with a survey. We will have a format and we'll collect the data, and then we using Pathfinder we will see how much shadow that can fall on the module. So the nearby area where the tall structure, tall trees, anything is available or not, those things we will see. And compass we'll be using to, in mobile we'll use compass, right? So we'll use for identifying the GPS location, measuring tape, digital meter we'll use, camera, an angle measuring equipment, notebook, and usually we'll go with the working partner so that it will be easy to handle the data collection. So first one is Pathfinder in this photo, and this is light illumination meter, and there is a compass and a distance meter, measuring tapes, cameras, and all those things we'll be using. And when we are selecting the area, we'll maximum see where shadow is not there, and easy access to the array for maintenance, PV module for maintenance. And we have to provide ample space below the module and all those things, especially for cooling purpose, because even if the module is getting heated up, then the efficiency of the module will come down. And also one more point we have to see is that where you are going to install, it should not affect the aesthetic system of the location. And also the other thing is the location should not be very far to the inverter. And also next thing is we have to see whether theft or any vandalism or any animal intrusion will be there in that land or not. So those things we'll see. And also we'll do a shadow analysis in as part of our simulation reports, like in PV Syst or other softwares. Usually there's a thumb rule: if there is a 1 meter tall, 1 meter object is there, at least till 2 meter distance there will be a shadow. So just by applying the rule, we will generally design accordingly. Either we have to decide whether to remove that object or whether we have to move the module a bit far away. And this is just one picture which will be just showing. For example, without shadow, if you see the first module is generating almost like 5.6 amps, and with small shadow 3.89, and furthermore it's 2.3. And furthermore shadow, if you see in the fourth picture, it is not even like 10% of the module size. It's almost getting down, reduced to 0.77 amps. So this is how the shadow effect will be on the generation. So usually we will work out without shadow, like wherever shadow is not available, we'll put the module there. So like that. And some of the case study we will see. One is Pavagada Solar Park, which is world's second largest solar park, almost with 2050 megawatt capacity. And their leased model, like I told you, leased model also got implemented. There they bought the land, or they leased the land around 21,000 per acre annually. And there are various challenges that they have faced. There is water scarcity, because water is to be required to clean the modules, to maintain the efficiency of the panel and all those things. A lack of local employment, also one of the challenge faced there. There are some of the environment concerns, like I told you, if any biodiversity is getting affected or any species are getting affected, then definitely project will have a concern there. So there was some environment concern also, but for that they have given some mitigation measures. And benefits, it will be like financial stability for the landowners, and contribution towards Karnataka's renewable energy targets and all those things. And especially lessons learned would be importance of community engagement and fair compensation, those things. And future plans for Pavagada would be expansion and integration of energy storage systems, BESS, large scale storage system, those things. And environment consideration, when you consider that conducting EIA, we have to do EIA if it is a project is covering some land area or something like that. And if it is a forest area, definitely EIA will be seen in a very strict way. Or else, if there is any forest area which is near to our land where the power plant is going to come, then again EIA would be major point to check. And also, government is trying to promote agrivoltaics as well, which I will show you in the coming future slides. Community engagement, yes, we are for that particular project. There is a huge job creation and economic benefits. Infrastructure development was there, and the entire state's financial stability is improving. Income generation for various communities. So those things are one of the major advantage for communities and all. And as far as financial models are concerned, there are various models. PPP, public-private partnership, where an investor or a third party will come and invest in the large projects, and they will sign a PPA with the discom, or else open access PPA with any off-taker industries or commercial consumers or something like that. And SECI's most of the model would be during they will sign a direct PPA with the IPPs or investors, and they will conduct a reverse auction. Whoever quotes less, they will be awarded the project. And there is other finance models would be like debt financing or equity financing and all those things. International funding is also coming into India, especially through World Bank and EDB. And there are grants that is available from the various international agencies, especially to develop. And some of the IT companies also allocating some funds especially to develop the communities through their CSR funds and all those things. In fact, we have implemented a couple of projects in a very remote village where they don't have any electricity access. We have developed some megawatt level projects over there to supply power to the village areas and government buildings like libraries, anganwadis, schools, like corporation hospitals, government hospitals, and all those places. And as far as challenging is concerned, yes, one is high upfront cost, and risk is also there. If something happens, any natural calamities or something happens, there's a huge investment, right? So that will be a risk. And as far as opportunities for innovation is concerned, green bonds and crowdfunding platforms can be used, especially for funding the projects. Yeah, risk always, because one is huge investment. That is one of the things, and addressing off-taker risk for financially unstable discoms. This point I already told you. Few discoms are there which delays payment very, like couple of months delays there when releasing the payment. So because of that itself, there are many projects are getting, the investors are giving less interest for those projects. And mitigating environment risk, yes, that is one of the risks that we have to manage. And construction risk, delays and overruns, quality issues, and all those things will be another risk. Financial risk, and then operational risk could be, suppose if you don't have any grid integration facility available, that is also one of the risks that we have to address. And the grid connection planning, mostly some of the projects we can do it with the line in layout, like Lilo, like in Lilo, what we do similar to that, we can do. And apart from that, sometimes we have to seek support from government to develop the infrastructure for that. And in order to avoid those kind of challenges, energy storage is one of the major alternative options we can take. And construction challenges, yes, labor shortage, transportation. If the area is not proper, and if there is not proper access to our site, then there is a problem. And partnering with local contractors, there will be some political issues will be there. The local MLA or MP can tell that you have to put these contractors for that. And if the quality gets affected, then obviously generation will be getting affected. There are various things. And just to share our experience, in a couple of our previously, I was working with various companies. A couple of our site engineers used to say that it will be very difficult when they put foundations for the large scale projects and all those things. And some of the local gundas and rowdies even attacked the engineers who have put in site. Those kind of problems also has been addressed, because the engineer will say you have to put M20 grade. He will not put them with that grade, and he will reduce the quality of the concrete and all those things. There are various challenges that should be faced. And operation maintenance strategies, yeah, suppose if the access is not there, then regular cleaning would be one of the problem. Regularly, we have to inspect the modules, inverters, and other BOS items, and proper training to be provided for the manpower who is going to work in the site. And drone-based inspection could be one of the future thing, and automated maintenance system. In many of the sites, which site has huge investments and all, They are putting like automated robot cleaning systems, drone based inspections, all those things we are implementing. But some of the projects it's yet to be implemented. But once the cost of those kind of technologies comes down, definitely that will be one of the futuristic thing, that is well promising for this kind of large scale projects. And China, how they are doing is even the floating solar types they are majorly developing, apart from the land based solar, and they are also focusing on large scale production of modules and all those things. Like most of the modules whichever is getting implemented in various large scale utility projects, mostly if approval is there, Chinese module only is coming. So I didn't want to name those modules, but there is a huge intrusion in our solar market also. And there are some lessons that we can learn from Germany's large solar parks. They were focusing majorly on decentralization and community-owned models for local support, and they have integrated agrivoltaics to optimize land use and supporting agriculture and all those things. Comparison policy framework, if you see, they have feed-in tariffs, and India has reverse auctions, and they have emphasis majorly on energy efficiency and smart grids and all those things. Smart grids are microgrids basically, where you can easily have a local community based power plant which can supply power only to that community. So like that, creating microgrids everywhere. And challenges faced by Germany is grid integration and balancing supply with demand. So there is a huge demand is there, but supply was less. An opportunity for collaboration which we like India can think of is knowledge sharing and on community engagement and decentralized system. There are various challenges which we already discussed: land availability, environmental impacts, grid integration, financial challenges, regulatory challenges, and opportunities, and political challenges also there whenever it comes to large scale projects. And some of the recommendation that what India can think of is focused on wastelands and drought prone areas where the plants or crops cannot be cultivated. Those kind of focus, and that we can focus on that. And community participation during planning stage to mitigate resistance. So because in many areas, if you see, once we prepare the land, leveling and all those things are done, when you put a foundation, that time sometime the dust and all will go to the nearby village. That time people will come and stop the project. Because instead of that, if we start engaging the local community in the first stage, like the initial stage, during the planning stage itself, like taking local laborers and taking panchayat support and helping the local communities by involving in any of the way of these projects, so then these kind of problems can be avoided. And we have to start to promote hybrid system combining solar PV, wind, battery storage, and also now green hydrogen and other things to, and also encouraging domestic manufacturing through PLI schemes. And the regulatory process streamline that. Anyway, government has to take a step on that, and now we are much more better compared to before 20-25 years. And we have to start investing more into energy storage technologies for grid stability. And we have to start focusing on international collaboration for technology transfer. Why I'm talking about technology transfer, like I told you in the first two slides, I'll come to the next. Actually, because there are many technology globally they have developed, and which we India really needs those technology to tackle our power requirement and all those things. And some of the future trends that we can discuss is one is agrivoltaics and expanding more and more ultra megawatt mega solar projects, and integration of BSS system for this mega scale projects, and advance of solar panel technology. This is what I was telling. Perovskite solar cells. I'll show you the pictures in the next slides. And there is something called space-based solar power research is also going on, and I'll explain about that also. And there are growing demand for rooftop solar and decentralized solar system. And some of the other opportunities like electrical vehicle EV charging through solar parks or solar PV panel. That power is used for charging the infrastructure for EV. Then the complete entire grid is getting green. So this is what I was telling. Agrivoltaics, the panels will be on top of the what, but some distance will be there, and this cannot be used for almost all type of plants where you have more clay soils, because the more water absorption will be there and all those things are there. So, and wetlands and all those things cannot be used for this. So wherever crops can be cultivated, maybe in a black soil, red soil, or something like that. So, and also the crops which needs less water, those kind of crops can be cultivated as part of agrivoltaic system. Because if you stagnate so much of water like how we do for paddy, there is a possibility that foundation there will be slight movement in the soil and all those things. So, and again, battery energy storage system, starting like implementing solar power to charge the battery system, and then charging the infrastructure through that, and then charging our EV through that would be another option, like integrating renewable energy with the BESS system. This would be our future strategy. This is what the perovskite modules I was telling about, which this is how the module layer will look like. The top layer will be metal, and there will be hole extraction, there will be perovskite material, electron extraction, and there will be IT1 and glass. So basically, that which includes basically this material, perovskite material includes methyl ammonium lead halide or cesium lead halide. This is basically organic and inorganic metal basically. So this will be either halide and lead based material only. The efficiency is coming more than 25 to 29 percentage now at the lab scale. So definitely there is a good potential or good future potential for this kind of modules also, apart from bifacial. And this is what I was talking about, space based solar power. How does it work? Basically, this was actually founded or funded by NASA. Basically, it was the technology itself was created by NASA, and they were trying to implement that in US now, and this may come in future maybe to India as well. So basically, the concept is sunlight is captured by solar power satellite and converted into electrical energy. So electrical energy is getting converted there itself in the sky, and then through wireless energy is getting transmitted in the form of microwave or laser beams right to the earth, and these energy beam is collected in a ground where we can call it as a receiving station, and that converted into electricity. So electrical energy now through electric beam it's coming, and then it is getting converted to electricity, and then the electricity is getting distributed to the power grid. So this is the entire this is just a summary of the technology I can tell as of now, because still now there are so many research that is getting happening in this area. And one of the challenge that I see is safety, because if you are just transmitting everything through wirelessly, and there are many electrical conducting material is available, and so how that challenge is going to be addressed, those things we will be knowing only in the coming futures. And decentralized energy system, microgrids, like I told you, microgrids can be one of the solution, and where small communities can be provided with solar power or wind power and all. As far as global best practices we can discuss, one is hybrid tenders, which USA is calling for with various this thing. China's floating solar parks. Even in India, we are now focusing on floating solar parks majorly. And Germany's community-owned model can be taken as one of example. Australia is majorly focusing on large-scale solar farms with energy storage. Even Tesla has a very big energy storage system there in Australia, and Japan's emphasizing on technology innovation and efficiency improvements of the modules. So those things can be taken, and technology transfer and joint research initiatives, maybe with NASA or something like that. If we jointly collaborate and work, there's a possibility that that technology can be transferred to India or something like that. So those kind of practice that we may have to follow, and for which the local regulatory and market condition needs to be lucrative, and it should be supportive as far as these technology transfer. When we focus on the growth of the country by through solar or through this kind of sectors, definitely local regulatory and market condition support, market support and local regulatory support is definitely required. Coming to conclusion, we have almost coming to the end of the presentation or webinar. So India's leadership role in renewable energy transition is concerned, we had a good policy support, but still policy needs to be somehow reframed or else modified according to the local condition, and technology innovation, community engagement, and international collaboration to be made. And we have achieved rapidly on solar capacity increase and also manufacturing capabilities. In the last 4 5 years, if you see, there are many manufacturers came into manufacturing brands have come. And as far as future prospects are concerned, energy storage to be linked to the large scale solar systems or utility scale solar system. And as far as challenges for us, what we can see is the balancing in economic, environment, and social consideration. And our one of the big opportunity is scaling up more on the agrivoltaic side and also the floating solar side, when you want to integrate the large scale solar system with the grid is concerned. And this ends our almost the presentation. The next would be like as our company, what we do, just one slide, that's it. So we basically work in renewable energy, energy efficiency, and environment and safety. In renewable energy is concerned, we work in solar EPC and O&M, end-to-end solution we are providing in solar. And in feasibility and only consulting portion we are giving with wind and green hydrogen. And in efficiency, we have energy efficiency is concerned. We are empaneled with Bureau of Energy Efficiency. and we are helping many customers and IPPs for attaining their energy efficiency targets and all those things. We do lots and lots of audits, like mandatory audits and all those things we do. And in sustainability, we do sustainable reporting and other areas, carbon footprints and all those things we do. And these are all our various global clients, I can tell. And I think, yeah, that ends our presentation. If somebody needs to get in touch with me, they can just email me or WhatsApp me in the numbers given. And if there is any queries, we can discuss.
Thank
Yeah.
you so much for these insightful session. We have two questions that the audience member have posted for you. I'll just read them out. The first one is for mounting structures, as there was mention of mounting structures in your slide. What all options are available apart from GI?
GI and MS are the mostly we are using as of now. As far as because the main thing is, the material what we are using, it should not be rusting. As far as large scale project is concerned, mostly we go with GI, because if you go the MS with anti-rust coating and all those things, after some time that paint will come out, and because this power plant has to be there at least for 20 years, right? So we don't take risk in that.
Okay. The next question is about the same. There's a new product which is commonly called as ZAM, zinc, aluminum, magnesium. Comes with a high corrosion resistance property. What are your views on using that as a mounting structure?
It is still under research. Global, I mean, vastly, if you see in many power plants, they have not started to use this ZAM. But I have also heard of this material. Basically, it has a very good resistance over the corrosion and rusting and all those things. But in market, it's not easily available. Not all the, because that material needs to be available, right, for implementing large scale project. So the availability of the material is also not that much in the market. So in future, maybe 4 to 5 years down the line, definitely there will be good. There will be more usage on this material.
Okay, thanks. A couple of questions have popped up new. I'll just read them out. So there's one question which asks, how are the space-based solar systems better than what we are currently using?
Actually, the thing is, now it's very early to comment, because it is getting communicated to the earth through microwave or else through beam. So definitely, as far as efficiency is concerned, since it's traveling through a long distance, definitely it cannot match the solar efficiency. And what I saw is maybe by 2050, maybe 50 megawatt hour or 80 megawatt hour only it can be transferred. Something like that I saw in the in some magazine or something like that. But still, it's under research. Maybe once somebody implements that, once government takes some chances, and once they start to implement, definitely well, like how I was telling, solar project which costed 17 crores per megawatt, and now it's almost 30% of the cost. So like that, initially the cost might also be very high, and not everybody can will be easily able to implement those projects. But as far as efficiency or performance is concerned, definitely our normal PV module will be having more efficient than that, because of the transport distance, travel distance, and all those things.
The next question is from Mr. Sayyed Atif. What should be the minimum gap between the panel and the mounting structure?
Actually, the panel will be sitting on the mounting structure only, so it will be below. In between, I mean, mounting structure will be, it will be connected through a screw only. Though there won't be much gap. But if you see between land, the ground and module, it may vary from 1 meter, half meter to 1 meter. The distance might vary. But structure to module, it will be connected through a screw. So definitely it will be intact with the structure.
Okay. Moving on. The next question is, what is the difference between BGL, GI, ZAM, and what is the preferred usage according to you for solar mounting structures?
See, I mean, I think like the other question was also similar to that. Like I told you, we have to see the material availability first, right? Which is available now. So mostly GI is mostly available in the market. So all the projects are getting implemented with GI. But as far as the usage, positive, like if you ask me which is better, definitely ZAM is better. But the availability of material, that is a major question here. Not many industries manufactures that, and maybe in future once the manufacturing is more, and the definitely now the cost is also much higher because of the not availability. So when the in future if the production is also more, when the demand is being met, so definitely the cost will come down. That time ZAM will be one of the major option to implement this kind of projects. But as of now, what we have in hand today, what is GI basically?
The next question is from Mr. Sandeep. What's your opinion regarding cooling of solar panels to increase overall efficiency?
Actually, the thing is in agrivoltaics, this is one of the concept. When you water the plants, the water is getting evaporated and it is going towards the module and all those things. So they are telling practically there is a slight variation in efficiency. The increase in efficiency is there. So positively, yes, if we cool the module, and there are some technology now which is coming up with where the automatic cooling system is also integrated along with module, but still it's not available in the market. So definitely, if the temperature is being maintained, there is a slight variation in the efficiency improvement. Yes, it's there.
Okay. The next question is, at what intervals cleaning of modules is required?
See, usually in all the projects what we have implemented, we use cleaning for 2 weeks once. But there are, if it is a dusty area where too much of dust is getting deposited on the modules very frequently, then weekly cleaning also is suggested. It again depends on the area, it varies. And there are some projects which got installed in Leh, Ladakh, and all. Too much of snow deposits were there, and they were doing almost 2 3 days once they are doing cleaning. So it again depends. But in India, where the normal arid region, whichever get the projects are getting implemented, 2 weeks once is the average cleaning that is suggested basically.
The next question is, which all criteria to be considered for based floating solar panel safe when compared to land solar?
Which all factors in the sense the material usage, that is one, the material whatever we are using, it should be anti-corrosive, and also because the cables and all will be going, the cables has to be immersed in water for long time. So those kind of things we have to clearly see, and proper protection we have to give for those cables. And these are all the things basically we'll have to see. And again, one of the major advantage in floating solar is the temperature of the module. It can be easily maintained, but in summer definitely the water will also get heated up, at least the surface water. So that is one of the challenge. But apart from that, these are all the things that we have to see: material usage, cable immersion in water, and other things. And floating material should be properly, and because the thing is, it is getting interlinked between each other, right? So that strength of the this thing, whether the life of that material is, whether it's more or less, that also depends.
The next question is, in case of roof mounting structures, what should be the minimum distance between the panel and the supporting structure to increase overall efficiency and help in heat dissipation?
See, when we again a roof, again there are two three types are there. One is sheet roof or else RCC. As far as RCC is concerned, similar to our ground mount, we will put a foundation, and then we will implement with. I mean, we'll put a structure and then we'll put the panel top of it. But the sheet roof is concerned, we will just put a clamp kind of MMS module mounting structure, and where we start installing or connecting the modules. Right. What was the question? Can you repeat? Can you just repeat the question?
Yes, so it was, what should be the distance between the panel and the
Yeah.
supporting structure? Yeah.
Okay. So basically, these things we will be deciding during the design stage. So we will generally get the as-built drawing. In as-built drawing, we will have all the nearby tall rise structures and everything will be there, and we will do the design. We'll do the design, and then that design will be getting simulated with PV or any software or something like that, and it will do a shadow analysis. And through that, we will decide how much distance we have to keep between module to module distance. So it is not like just like that we'll put a distance. It will clearly show how much distance we have to keep. It will consider summer solstice, winter solstice, and the sun path movement, everything. And then for the entire year it will show, okay, even at the high peak summer when the shadow will fall, it will fall up to maybe 50 centimeter. So we will have to plan something beyond that. So those kind of things we will do in software, and when designing we will come to a decision how much distance we have to keep. For that we will take a help from PVSys, Google SketchUp and all those things.
Okay. Last few of the questions. The next is from Mr. Sachin. What is the typical weight per megawatt with mild steel or let's say ZAM? Is there any ratio between the weight and land type?
See, basically aluminum structure is always lesser in weight. As far as GI or MS is concerned, definitely there is a weight, I mean, value structure weight is a little bit more. There is a thumb rule. I couldn't recall that. Usually the load would be per megawatt some 5 tons or something like that. I'm not able to recall that. But something in that range only it comes. Structure per megawatt, something like that range it comes. But exactly I'm not knowing the value. But somewhere I saw it's 5 tons or something.
The next question is from Althi. Hi, sir. Good evening. What is the best position way to keep the solar panels for maximum power generation? Is it possible to have automatic rotation that aligns with the sun?
So see, usually there are two types: fixed tilt and tracker-based mechanism. In fixed tilt, what we generally do is we'll keep north-south direction because of this thing. The sun moves from east to west, so we'll generally keep north-south direction. We'll keep, and tracker would be, there are again 2-3 types are there. Timer-based tracker is there, so automatically it starts. We'll keep the timer at 6 o'clock, and every hour the sun the portion of the module also gets rotating according to the sun's direction. So there, at the tracker-based mechanism, again the efficiency is much more higher. So yeah, there is a possibility. Yes, we can also keep a rotating mechanism for a module.
Okay. Is it really possible for taking up like some agri activity in between panels for agrivoltaics model? If so, what can it be and what are the associated risks with it?
Yeah, I think I answered that. I will show you the picture. So see, this is already been followed, not in India, but usually outside. So we have to select a crop in such a way that where the water usage is less. Secondly, the soil type should not be like water holding soil, like moisture content of the soil should not be more, so that it hold more water and all those things. So those kind of lands can be used, and these kind of agriculture activities which has been already followed somewhere in foreign, definitely that can also be followed here also. The main thing is we have to put the structure, like the height of the structure should be more, so that people can walk in between and do the agriculture activity. And some of the crops I can tell is maybe grapes, whichever is, it's a creepy this thing which can creep on the ground, the vegetation I'm just telling. So those kind can be done, and watermelon plantation. So wherever that height of the vegetation will not go high, those kind of plantation we can do, or vegetables, you know. So those kind of plants we can plan for the agrivoltaic systems.
Okay. The next question is based around recyclability and reuse of the solar panels. So from Manas Day, are there any studies on waste solar panels and its management and reuse? How big is the panel waste reuse?
See, right now, yeah, that is one of the major challenge, to be very frank. Because like 15 years back, whatever modules got implemented, like polycrystalline and all those things, now the waste is getting generated. Right now, the disposal mechanism would be like there is no proper policy is yet to be framed for this, and because the module has aluminum, glass, and other semiconductor cells and all those things, right? Cables. So usually, it's how our kabaddi wallahs are disintegrating the existing scraps and all those things. That is how it is been right now. It has been made. The aluminum is extracted and it will go to a aluminum industry for recycling, and the cables inside the copper wire inside the cable and all those things, that is getting extracted and it's going for recycling for the copper industry. And similarly the glass is also getting extracted, and then so like that the breaking is happening, and then according to the industry requirement, for those industry sectors it's getting transported. But the thing is, in many countries they started importing to the other neighboring countries, like with the panel waste and scrap and all those things. but we have anti-dumping policy also. So because of that, we are still figuring out, and there are many World Bank studies are there how we are going to tackle this panel waste that is going to be generated. Not only panel, even the turbine waste and all those things. At least turbine, we can tell it's a fiber material. Again, it can be easily recycled. But here, there are some challenges which cannot be recycled. Usually, mostly 80-90% can be recycled in modules also. Only thing is the cell waste, which cannot be again put it together. So those, for that alone, we have to see some kind of technology, whether it's innovation is happening or not. But apart from that, the other materials can be easily recycled.
Okay. I think that's it. Thank you very much for patiently answering all the questions. A very heartful thank you to you for taking out time and sharing across valuable insights for our viewers. Also, to all the participants, thank you for tuning in and actively participating through your questions. Please stay tuned for our next webinar. We'll keep you posted and we'll explore more innovative product solutions in the space. Thank you all.